right, a couple more problems from section 5.3 that I would like to take a look at. The next problem is sort of a theoretical problem, but it does say, what is wrong with the following equation? So this problem attempts to find the value of the integral from -3 to 2 of 8 over x cubed dx. It evaluates it as -4 over x squared, again on the interval from -3 to 2, and gets an answer of -5/9. The problem here, I think, becomes a little more clear if we look at it graphically. So I provided here for you the graph for the function 8 over x cubed. And you can see that if we try to go ahead and shade all of the area that's going to be captured here, we're really talking about, let's see, from -3. So it's really all of this area. I'll just roughly kind of draw that for you. And then also the area on this side will be from 0 to 2. So you see that the issue here is over here, where do we stop shading? Also down here, where do we stop shading? So the problem here is that this function is not continuous on the interval from -3 to 2. And specifically, it is not continuous at 0. So we are not able to integrate this function over 0. Right? So I'm going to select here as my answer. I'm going to say that this guy right here, let me choose a different color. Right. So this option says that the function is not continuous on the interval from -3 to 2. So part 2 of the fundamental theorem of calculus cannot be applied. And we can see visually why that is the case. All right, another problem from 5.3 says let f of x be equal to the integral from 3 to x of e to the t squared dt. We would like to find an equation of the tangent line to the curve y equals f of x at the point that has the x coordinate of 3. So I will remind you, whenever we're asked to find the equation of a line, there's 3 steps. So for the equation of a line, right, there's 3 steps. So the steps that we're going to follow, number 1 is that we would like to find the slope. Step number 2, we need to find a point that our line is going to pass through. And then step 3, we will use that information and we will put everything together using the point slope form of the equation of a line. So step 1 here, let's go ahead and find the slope. So we know that slope equals derivative. Slope equals derivative. So I will find the derivative of this function. So the derivative of f of x, again, derivative of an integral. Note here that we are in case number 1 of the fundamental theorem of calculus. So we simply need to just replace the variables. So that derivative will be e to the x squared. So to find the slope specifically when x is equal to 3, f prime of 3, so this will be e to the 3 squared. So this is e raised to the power 9. And so there we have it. The slope will be e to the power 9. Step 2, all right, step 2 would be to find the point. All right. So let's find the point that we are passing through. So I will take my equation f of x and I'm going to evaluate it at 3. So what this gives is the integral from 3 to 3 for e to the t squared dt. Now, I don't really care very much exactly what your function is. If you're integrating from 3 to 3, that results in a 0 area. I'll write that over here. So this integral definitely equal to 0. So this means that the point, our point x naught, y naught that we're passing through is going to be the point 3, 0. So now we can move on to step 3. And step 3 would be to use the point slope form. Y minus y naught is equal to m times x minus x naught to find the equation of this line. So I will plug in y minus 0 is equal to, my slope was e to the power 9, and then x minus 3. So let's see, we can go ahead and distribute here. I will get that y is equal to e to the power 9x minus 3e to the power 9. All right, and this is it. This is the equation of the line that we set out to find. All right, one more problem from 5.3. Says if f of 3 is equal to 15 and f prime is continuous, we know that also the integral from 3 to 6 of f prime of x dx is equal to 16. What is the value of f of 6? Right. So I'm going to start by noting here that just by simply plugging in, we can go ahead and see that if we just evaluate this integral, if you evaluate f prime of x, your integrand is f. And by applying the fundamental theorem of calculus, this integral will be equal to f evaluated at 6 minus f evaluated at 3. But the problem gives me a hint here and tells me that the integral is equal to 16. So therefore, we can tell that f of 6 will be equal to 16 plus f of 3, which is equal to 16 plus, and again, the value for f of 3 was provided. That's equal to 15. So I get a value here of 31.